In this lecture, we will learn about the iterator design pattern and how to implement it in Python. Iterator is a behavioral design pattern that lets us traverse elements of a collection without exposing its underlying representation. Collections are just containers of objects. We treat them the same with this pattern regardless of if the collection is a list, stack, array, tree, etc. When do we use the iterator design pattern? We use this pattern when our collection has a complex data structure under the hood, but we want to hide its complexity from clients. It is also used to reduce duplication of traversal code across your app. Iterator is great for when we want our code to be able to traverse different data structures, or when the types of these structures are unknown beforehand. Let's look at the pros and cons of using the iterator design pattern. The pros include that it promotes reuse by hiding implementation. It follows the single responsibility principle. We can implement new types of iterators and collections without breaking anything. And we can use it to delay an iteration and continue it when needed. The cons of using this design pattern are that it can be overkill if your app only works with simple collections. It may be less efficient than going through elements of some specialized collections directly. A client may modify the elements, damaging them. And it is difficult to implement to support both iteration and modification. Let's learn how to implement the iterator design pattern in Python. First, we will create a class named person. Inside of this class, we will create a variable named age, set to an initial value of 0, and a variable named name, initialized to an empty string. Inside of this class, we will have the init function that takes in 3 parameters, self, age, and name. Inside of the init function, we will set self.age equal to age, and self.name equal to name. Next, we will create a class named person collection. Inside of this class, we will create a variable named position, initialized to a value of 0, and people list, initialized to an empty list. Then we will define the init function that takes in the self parameter. Inside of init, we will set self.position equal to -1. Then we will append some people to the people's list. Let's add a person age 25 named Rob. Then let's add a person age 23 named Sarah. Next will be a person age 30 named John. Finally will come a person age 41 named Peter. Next we will create a function named current that takes in the self parameter. Inside of this function we will return self.peoplelist at the index of self.position. Then will come a function named moveNext that takes in the self parameter. Inside of this function we will increment self.position. Next we will return the result of self.position less than the length of self.peoplelist. Finally will come a reset function that takes in the self parameter. Inside of this function, we will set self.position equal to -1. Time to test our code. The first step will be to create a variable named collection of people and set it equal to an instance of the person collection class. Then we will have a while loop that iterates while collection of people.moveNext. Inside of this while loop, we will create a variable named person and set it equal to collection of people.current. Then we will print out person.name, then a space, followed by person.age. When we run the code, notice that the elements of the person collection were iterated over, meaning that our code worked. The iterator pattern is especially useful when you want to create your own custom data structures that can be iterated over. In the next lecture, we will learn about the mediator design pattern and how to implement it in Python.